um, in general, we have y equals ax to the n. So any expression in this form, there's a number before the x, can be any number, and then there's a number n, also any number, such that if we will be getting the derivative dy over dx, the rule is a times n x to the n minus 1. So meaning to say, we multiply the a to the exponent n, and then x gets a new exponent which is 1 less than the original. So for example, if we have y is equal to 3x squared, then the derivative, which is denoted by dy over dx, this is equal to 6x. 3 times 2 is 6. X, because x to the 1 means 2 minus 1. Or x to the 2 minus 1. Right? And this rule can be extended even if you have something like 4x cubed minus 5x squared plus 3x plus 4. You can get the derivative of y by getting the derivative of each term. So 4x cubed becomes 12x squared minus 10x plus 3. And that's the derivative. Right? So that's the basic rule. The moment you understand the basic rule, we can extend it to the more advanced type of expressions. Let's say, what if we have y is equal to x plus 1 times x plus 2? What do you think should we do if the expression given is y is equal to x plus 1 times x plus 2? Any suggestion? Expand. Okay. So, take note that the rule will apply for ax to the n. The x plus 1 times x plus 2 is not in the form of ax to the n, because you have an x plus 1 times x plus 2. The rule cannot be applied immediately. Okay, but you suggested we have to expand. What is the expanded form of x plus 1 and x plus 2? X squared plus 3x, that's x and 2x, plus 2. And there you have x squared as ax to the n, 3x as ax to the n, and 2 as ax to the n. Diba? So lahat na yan. And then, we can now get the derivative. So this is equal to 2x plus 3. Yan. Okay. Now, so we have seen a basic one, and then we have something that should be expanded before we can apply the rule. Now, there will be cases in which the exponents are not simple. For instance, y is equal to x to the 2 over 3 minus the square root of x plus 1 over x squared. And all of a sudden, the expression is a bit different, but maybe we could think of it still as ax to the n. This can be changed to ax to the n. This can be changed to ax to the n. Right? So before we apply the rule, we have to change the expressions. We can now retain x to the 2/3. That's still fine. What about square root of x? X to the 1/2. You need to know how to change radicals to exponential, expression with exponential, with fractional exponents rather. 1 over x squared, x raised to negative 2. And every term now is in the form of ax to the n. Then, we are ready to get the derivative, dy over dx. The rule says a times n. 2/3, that's 2/3 times 1, x to the negative 1/3, that's 2/3 minus 1, and then minus x to the 1/2, x to the negative 1/2, and then plus or minus 2 x to the negative 3. So minus 2 minus 1 is negative 3. Okay, if we are not required to simplify, then we are done with the process. But sometimes we need to find the simplest form. Simplest form means negative exponents are not allowed, fractional exponents are not allowed. Okay, so maybe we can take just one more step, because after that there's still another process. How do we make these terms with positive exponents? What will happen to the first? 2 over 3 x to the 1/3. The negative exponent becomes a positive exponent. Minus 1 over 2 x to the 1/2. And then minus 2 over x to the positive 3. And there is still another step. Okay, although in the test you will not be required to do the multi-step for this, but to give you a knowledge on how, this is 3. How do you change x to the 1/3 in radicals? Cube root of x minus 1 over 2 square root of x minus 2 over x cubed. And then we rationalize. So this is 2 over 3 cube root of x. We'll multiply this by the cube root of x squared. Cube root of x squared. Bakit cube root of x squared? So that it will match the cube. So x and x squared will become x cubed. They will cancel. And then 1 over 2 square root of x. Square root of x. Square root of x. Tama? And then minus 2 over x cubed. And finally, what will be our final expression? 2 cube root of x squared over 3x minus square root of x over 2x minus 2 over x cubed. Okay, so don't worry. For the for the test, for the quiz, we'll limit it until here. I just want to see if you can apply it. Okay, why did I do this? So that you will know that we can still simplify. Any question? So we have seen 3 main types now. The basic one, the polynomial expression. The second one, a product that can be expanded. And then the third one, what if the exponents are unusual? Okay. So let's go to the more complex. We have, say, another example. Y is equal to x squared plus 5 raised to 2. Let's make it bigger. Raised to 4. Raised to 4 times x minus 3 raised to 2 divided by x plus 1 raised to 5. Okay? Best material, diba? So, obviously, it's no longer in the form of ax to the n. And at the same time, if we plan to expand x squared plus 5 to the 4, that will take some time. Even dividing it by x plus 1 to the 5th. So, if the expression is this complex, we now need more advanced rules. Okay, and let's talk about rule number 1. Anong rule na alala niyo before? Okay, so bigyan ko kayo ng example. Liitan natin, x squared plus 5 raised to 3, tapos x plus 1. What rule is used to find the derivative of this? May name yan. May mga names yung mga rule natin. It is, diba? From the expression itself, this is a product of two expressions. So we need to apply the product rule. Do you remember the product rule or product law? Okay. I'll state it formally and we'll apply the rule to the given expression. Maybe we'll try to limit it first without the exponent 3. Okay? Suppose another function, medyo formal tayo, f of x times g of x. And h of x is the product of f of x and g of x. So how do we find the derivative? Now note, if we are going to write the derivative and the function is written as h of x, we use the symbol h prime of x, right? We have that symbol on top. The rule is we copy the first and then get the derivative of the second, plus we copy the second and then get the derivative of the first. Okay? In this course, we will not prove that anymore. Okay? That's for the advanced course. But we have the rule f of x times g prime of x plus g of x times f prime of x. Meaning to say, copy the first, differentiate the second, plus copy the second, differentiate the first. Okay, so like what I've said earlier, let's try to limit it now without the exponent, and then x plus 1. Well, we can say that's still easy to expand. Okay, but let's apply now the product rule. So imagine this, or take x squared plus 5 as f of x, and x plus 1 as g of x. So what will be our dy over dx? By the rule, we copy the first, derivative of the second is 1. And then plus, we copy the second, and then derivative of the first, 2x. And if the expression is, or can be simplified easily, then let's simplify. X squared plus 5 plus 2x squared plus 2x. Arrange or combine like terms. 3x squared plus 2x plus 5. And that's the derivative. You will also get that by expanding x squared plus 5 times x plus 1. Okay? And immediately after the product rule, the second rule is the quotient rule. So we have a new h of x equals f of x over g of x. Okay, h prime of x in this case is g of x times f prime of x minus. Okay, we subtract. This is f of x times g of x all over g of x, which is raised to 2 or squared. Okay, some teachers use this way to immediately memorize the formula. Let this to be h, that's high, and let this to be l, that's low. So they say, so that's l dh minus h dl over l squared. So they say low d high minus high d low over low squared. To easily remember it. Okay? May question? Okay, so let's go back to my example. Wala pa. Say, suppose we have h of x is equal to x cubed minus 4x divided by 2x squared plus 1. So as we can see, it's a quotient. So we will be applying the quotient rule. So solution, so always use proper signs. So h prime of x is low, the high is 3x squared minus 4 minus high x cubed minus 4x. The low is 4x all over 2x squared plus 1, which will be squared. Okay. I think we can still simplify. Hindi pa naman ganun kahirap. FOIL. Numerator. 6x to the 4th. And then, sige, sulat natin. 3x squared minus 8x squared minus 4. Is that correct? Okay. Let's close this with a parenthesis. Minus, let's put the 4x inside. To the 4 minus 16 x squared. No need to expand the denominator unless it is needed. Okay? Like this, if this is a multiple choice test and you see the denominators in the choice is all expanded, then you are forced to expand. So this will become, isulat muna natin, 6x to the 4th plus 3x squared. Let's simplify 3x squared and 8x squared. Minus 5x squared minus 4. Remove the parenthesis in the second. That becomes minus 4x to the 4 plus 16x squared again. Copy 2x squared plus 1, which is squared. And finally, combine like terms. 2x to the 4 plus 11x squared minus 4, correct? And then 2x squared plus 1 raised to 2. So this is our h prime of x. Yan. Okay, gets? Okay, the third one that will complete the set. Rule number 3. The chain rule. Example, y is equal to 4x squared plus 2x raised to 5. Again, if we can expand, then we expand. But there are cases in which the exponents are already large, so it's no longer practical to expand. But we only have the product rule and the quotient rule. Product rule cannot be applied there directly. Quotient rule cannot be applied directly. So in the case of expression with exponents, we use the rule called the chain rule. Okay, the chain rule is like the extension of the power rule, ax to the n. Okay. So the first rule that we had, although I didn't name it, it's the power rule, the basic one. If you look at it, the a here is 1. You don't see the number, but the a is 1. This is like the x, and then the n is 5. The chain rule is the extension of the power rule. So that means, in this example, we have 5 times 4x squared plus 2x raised to 4, because it's 5 minus 1. But there's an extension to this, and it will be multiplied to the derivative of the 1 inside the parenthesis. It's like the tail of the derivative. Sometimes they say it's the tail of the derivative. This is 8x plus 2. Okay? And then maybe we can just put the 5 together with the 8x and 2. So that's 40x plus 10. and then 4x squared plus 2x raised to 4. In most calculus courses, they will not ask you to expand that anymore. Okay? It's no longer practical. So you can just leave it as 4x plus 10 and 4x squared. Some even just consider the first one, and that's it. What is important is you know how to apply the rule. Okay, so let's generalize. So in general, if we have h of x, which came from a number a, f of x, which is raised to some n, the h prime of x is equal to a n, that's a times n, fx raised to n minus 1, and then you always have to multiply by the derivative of f of x. So that's the general rule. Okay, but the processes can be easily followed. So three main rules. Well, the four, yung power rule. So power rule, product rule, quotient rule, and the chain rule. The other questions will be the combinations of the rules. Okay, now we can go back to my very first example. Saan na yun? Ito. Diba? So it's an expression with a quotient, because it's a fractional expression, and the quotient has a product, and the product has something that you'll require. Okay, but we will do this later on, not today. Okay, but you might want to copy and try it at home. Okay, so that's for the first set.